sines and cosines, which means we have to worry about gang signs.
No. Like the ones that were appearing on the board last semester?
Yes.
That's not, is that a graph?
Yes.
No, that's like enlightening the public though, that's not.
Will you for once just not be so literal?
I didn't understand.
No.
Oh, I just signed, okay, I get it.
Anyway, so here's where we go. We talked a little bit about this yesterday. We're talking about your H's and K's again. What's going to happen here, guys, is that we've got your generic form of y equals a, bless you, sine of b x minus h plus k, where your h is your horizontal shift and k is your vertical shift. Just like every other one of these problems as we've gone through before, the h is always going to be the opposite value, and the k is always going to be whatever it is. So if it's x minus 3, that means you have to move it to the right 3. If it's x plus 3, you move it to the left 3. It's always the opposite signs. K value is always the same. One of the things that you will see is that, excuse me, as we go through these problems, you can have a negative a value. That just means that instead of going to the positive first, you go to the negative first. We did a couple examples like that, or at least we did one example like that yesterday. The way that we shift these things, just like we have ever shifted any other problem, we're going to graph the parent function. And basically what you guys did yesterday was graph parent functions all day. That's all those problems were parent functions. Today you're going to take that parent function, and we're going to list the ordered pairs and move them, and then replot them. Very, very, very simple. Right. Sine and cosine work the same way for the way that it looks. All the same rules apply as it did yesterday about your A and your B for your period. None of that changes at all. Just that fact that we have an H decay to worry about. Everything else is just the same. So let's take a look at, and I'm not really worried about all the words in here. Basically boils down to, again, horizontal for H, K is your vertical. You will see this plus K sometimes tacked out in front. It might say 2 plus sign of something. It might say negative 3. They put it on either side sometimes, depending upon the problem. Sometimes they throw this in parentheses, sometimes they don't. H, if there's an H, it'll always be in parentheses. If there's no H, there's no parentheses. That make sense? You'll see that when we go through these things. So let's take a look. Right off the bat. I have y equals negative 2 plus 3 sine of 4x. What do you think my first step is going to be?
Parent.
Well, yeah, we'll graph the parent. Before I even do that, what am I going to do? Yeah, write down everything. Just like we've done every single time whenever we have A, B, H's, and K's, we're going to label it all out. What's my A value? B. H. Good. H is 0 because there's no parentheses. K is negative 2. So what are we going to do to the parent function? Yep. All we have to do is plot the parent function and then shift it downwards 2. So if our A value is 3, what's my amplitude? Good. What is my period? Pi halves. Pi over 2. Everybody okay with that? Remember, your period is always going to be 2 pi over b, or the absolute value of b, excuse me. So it's pi over 2. This is a sine graph. If I know that I'm going to shift it downward, one of the suggestions I might make is to make the y-axis a little bit longer, because you know you're going to have to move it downward. Same thing goes for when you go to draw it out. If you know you have to shift something to the left, maybe bring that tail over a little bit further. If you got to shift it to the right, make it move over a little bit further so you have a little bit more space. Again, we're going to mark off our period. We know it's going to end at pi over 2, and it starts at 0. What's halfway between pi over 2 and 0? Bless you. Pi over 4. What's the next halfway point between pi over 4 and 0? And then in between here is? Very good. Our amplitude is 3. Now sine, where does sine start? 0, 0, very good. Then it goes to where? It goes to the a value. The a value here is 3. Then where? 0. Then where? Then where? Okay, so what we have now is that parent function. Everybody okay with that? Now, there's a couple of ways that I like to do this. First couple times I write this out, I'm going to go ahead and do my sets of ordered pairs. All I did there was just write out my 5 ordered pairs for those 5 points we just plotted. Nothing too fancy. You can see how it starts at 0, a value, 0, opposite a value, back to 0. Just like we talked about yesterday with sine. We always follow that exact same pattern. I know that there is no horizontal shift to this problem, so all of my x coordinates of these ordered pairs are going to be the same thing for the next grouping. Do you guys all agree? So I know that the shift is going to be at 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. What are all my new y values? What is it? Negative 2. Then what? Plot it. So negative 2 to 1, negative 2, negative 5, negative 2. And then shift. It's that straightforward. Do not be surprised if on the quiz that I ask you to write out your ordered pairs. Because I probably will. I'm assuming it's not that scary, is it? The weird ones are going to be when you have to worry about your horizontal shift and you have to work with your fractions. That'll be the worst part for you guys. Because I know how much you do on the fractions. Just parts of the time. I read that line. It's not even close to the point. It really wasn't, but thank you. Let's do one that has a little bit of both. Let's just jump right into it. Y equals 2 cosine of 2/3 times the quantity x minus pi over 4. First things first, A, B, H, and K. What's A? What's B? So A is 2, B is 2/3. What's H? Good. Do we have a K here? And there's no vertical shift. Amplitude? Period. Remember, your period, when you have a fractional b, take 2 pi times 3 over 2, and what do you get? 3 pi. Are we okay with that? Remember, what we're doing here, since instead of dividing out by 2/3, I'm just multiplying by that reciprocal right off the bat. Whenever I have that fractional b value, just a little bit cleaner. You all right with that? Okay, let's just make sure. So, the period? Remember, the period is equal to 2 pi over b. In this case, it would be 2 pi divided by 2/3, which is 2 pi times 3 over 2. All I'm doing is just shortcutting the multiplying by the reciprocal. So I get 6 pi over 2, otherwise known as 3 pi. Is that cleaner? Yes. So here's our period at 3 pi. It's a cosine graph that's going to get shifted to the right pi over 4. So when I draw out my graph, instead of putting my 3 pi at the very tail end here, I'll move it over some. That way I have some room to move things to the right. Does that make sense? I'm kind of foreshadowing what I'm going to do. So, what's your halfway point? 3 pi over 2. What's that one? 3 pi over 4. And this will be excuse me. Is that right? 5 pi over 4? 3 pi over 4 plus. Yeah, 9 pi over 4. Yeah. I'm just looking at it like, wait, that's not enough. That's not enough quarters. So, from here, does everybody see how we have to add pi over 4? One of the suggestions I might make is to rewrite these two guys underneath them in terms of the other fraction. 3 pi over 4 is what? In terms of 4 of a denominator. Yes, thank you. I'm sorry, I was looking at it. This is the same thing as saying 6 pi over 4. This would be 12 pi over 4. Just so I have it right here, it'll be easier later to add to it. Does that make sense? So go ahead and start with our cosine graph. Cosine starts where? 0 or A? A. Very good. Starts at A, then it goes to 0, opposite of A, 0, and A. Which gives me 0 and 2. 3 pi over 4, 0. 3 pi over 2, negative 2. 9 pi over 4, 0. And 3 pi back at 2. So here's our parent function. To each one of those x coordinates, we're going to add pi over 4. The y coordinates all stay the same. So that gives me pi over 4 and 2. What's 3 pi over 4 plus pi over 4? Pi. 3 pi over 2, which we've already written as 6 pi over 4. Add a pi over 4, we get 7 pi over 4. 9 pi over 4. Add a pi over 4, we get 10 pi over 4, which is 5 pi over 2. And then 12 pi over 4, add a pi over 4, we get. Does everybody see how the worst part of these problems is just adding fractions? It's really all it is. It's the worst part. Now, when I'm looking at my graph here, I don't have any of those x values on my graph, do I? We'll have to just put them in. Pi over 4, 3 pi over 4, excuse me, pi. 7 pi over 4, 5 pi over 2, 13 pi over 4. One of the things that I probably won't do on a graph like this, since I've listed out my ordered pairs, is everybody agree that if I start putting in all those extra ordered pairs on that number line, it's just gonna get real messy real fast. I might just leave it like that because I have my other set of ordered pairs already showing where the shift went. If I know visually it's gotta go to the right and I just plot everything over to the right, but I put my tick marks in, I think I'm okay with that. I think it's specifically knowing that you have those ordered pairs right in front of you is kind of the legwork of the problem. That's kind of the legwork. That's really the trickiest part of this, is just adding fractions. It's just really just getting fractions. Bless you, that. Thank you. It's kind of early. Okay. Let's change this. Let's say it's a -2 sine of 4. What's that?
Can we have a K too?
Sure. Give me a K.
12.
12.
I said 4.
All right. You know, since this looks messy, I'll tack this on back here because there's a
Is
parentheses.
that what it usually will be, or will it usually?
You know, they move it back and forth sometimes. It depends on what the A value is. If the A value is negative, it's usually the -2 value would come first. If there's an H, they tack it in parentheses, they'll put the K at the end. If there's no H, they usually put it up in front. You see it move back and forth a lot. So if you want, why don't you take a couple of minutes and there's an H, there's a K, and have fun.
You don't specifically ask for ordered pairs.
I'm going to ask for ordered pairs. Go ahead and give me ordered pairs of your non-shift and then your shift for those 5 points. You'd probably find out that this one really isn't as... Alright, so our A value is -2, B is 4, H, pi over 2, K, 4. So my amplitude is 2. Remember, your amplitude is always the absolute value of A. Your period is going to be how much? Pi over 2. The period is going to be at pi over 2. So I start, excuse me, start my sign. Bring out pi over 2 here. Pi over 4. Pi over 8. Pi over 8. -2. So we have 0, -2.
Wait. We started 0, 0 since the sun.
Did I just graph that as a cosine? I did, I'm sorry. I did, didn't I? Sorry about that.
It doesn't feel way wrong here.
No, it was me. Let's see if this will work. I thought it was, for some reason I thought this was a cosine. Pi over 8, -2. Pi over 4, 0. 8. To these problems, I know I have to move everything to the right, pi over 2, and up 4. So the easiest one to do first is what's pi over 2 and pi over 2? Pi. What's 0 plus 4? So I know this one's going to be at pi and 4. I also know that this one is going to be at pi over 2 and 4. I know that, let's see, pi over 4. So I want to add pi over 2 to that. I'm going to add 2 pi over 4. Okay, 3 pi over 4. Is it okay that I'm going out of sequence to do my ordered pairs? I'm just picking ones that are a little bit cleaner to work with first. Now I have pi over 8, and I have to add pi over 2, so I'm going to add 4 pi over 8. So I get 9 pi over 8? No. 5 pi over 8, excuse me. And negative 2 and 4 gives me positive 2. 3 pi over 8 and 4 pi over 8, yes.
Whenever I CDO, it annoys me greatly when you go out of sequence. Yeah.
Nicely played. He was trying to make it funny. It wasn't as funny as bullshit, but you know. You attempt to say. Okay. So here we have our new ticks. Pi over 2 and 4. Bring this up a little bit. 5 pi over 8. And 2. 3 pi over 4.
Oh, it's the other way because it's a negative.
Yeah.
You made it so your graph goes upwards.
Oh, yeah, yeah. So we're at 0, pi over 4, and pi over 2 and 4. Then add 2, we're at. Oh, I'm out of my, yeah, I'm just trying to figure out where I'm all out of space here, that's all. I didn't bring the graph down far enough. But yeah, anyway, we wrote our ordered pairs. It looks like that.
What? But you.
I wrote my ordered pairs. I know which ones are right.
It's graph. At least mine looks better than yours. Yours looks like shift.
Oh, it's bad, right? All right, let's do a couple of these for tonight. Tomorrow we'll combine everything and do tangents with the regular and the shift work of tangent. Let's do, this is page 845. I'd like you guys to work on 38 and 43. Can you repeat that? Can you repeat that? Okay, we're good. You sure? On 8:45, I'd like you to go 38 to 43. And then I want to do a couple of these translated ones to get 50 and 51.
50 and 51?
And 53 and 54.
Are you going to write that in the margin?
I'm going to. I'm just putting them all on the board real quick so I have.
So 50, 51, 53, 54.
Again, 38,
They're laughing.
43,
Can you write on the board?
50, 51, 53, and 54. Again, page 845. Okay?
Hey, Mr. Sir.
Yes, sir.
Can you write it on the board?
Because you can't write it down?
I think, I like to say paper, copy fire, so I just look at it on the board. Well, you've already done.